Hello and welcome to the less than 5-minute explanation and demo of Azure Serverless Computing. But before we dive into that, let's first talk about the evolution of the application platform. At first, there was the on-premise data center model where we had to worry about every single detail starting from hardware, networking, and power outages. Then we moved to the cloud infrastructure as a service model, which eased a lot of the burden, but we still had to deal with patching and right-sizing the servers. In order to address and remove most of the issues we faced with the infrastructure as a service model, it came the platform as a service model. But here again, we had to still choose the right operating system in which it would run and also dedicate some reserved compute capacity, which means you had to forecast the demands in advance. Now, by removing all of the traditional barriers for deploying and building software, we came up with the serverless computing model, which helps solve a lot of the business needs without the required complexities. Traditional apps are designed to conform to the infrastructure that they are built on, whereas serverless apps offer an app-first model by abstracting away the infrastructure and relieving the developer of the operational complexities of running those applications. So with serverless, all you have to do is provide the code for your solution or define the logic, publish it to the cloud, and the rest is automatically taken care of for you. Now let's look at some of the benefits of serverless computing. The first and foremost is the micro billing. Micro billing means you only pay for what you use, and you only pay for the amount of time that your function ran. You do not pay for any idle capacity whatsoever. The next obvious benefit is the reduced DevOps needs, which means you have a faster time to market. Now let's look at some of the components which make up an Azure Serverless Computing model. First and foremost, we have our Azure Functions. Azure Functions lets you run your custom code on demand without really having to worry about where it's running or its scalability. The next component is Azure Logic Apps. Logic Apps is a visual workflow designer. It lets you design workflows and orchestrate Microsoft and other third-party services, including Azure Functions. This is not just serverless, this is codeless. Next, we have our Event Grid, which manages all the events that can trigger your code and your logic. Consider an example. Let's say people upload pictures to your website and you automatically want to resize the image. That is where Azure Function comes in. Azure Function listens for an upload event, and as soon as someone uploads an image, it automatically resizes the image for you. Now that we have understood the Azure Serverless Computing model, let's dive deep into the implementation. So here's what we'll be doing in our implementation demo today. Every time a person tweets with an image and a predefined hashtag, our Azure Logic app will use the Azure Face API to analyze the image and send the age of the person in the image via email. Does it sound complex? This is where you'll realize the power of serverless computing. All this can be done with zero code and no previous knowledge of Azure Logic apps whatsoever. So let's get started. Step number 1 would be to go ahead and create the Face API. You can do that by going to Cognitive Services and then choosing the Face API option. Once the Face API is successfully created, we can move on to step number 2. Step number 2 would be to create our Logic app and link our Twitter account. We can do that by going to the Logic app tab and creating a new Logic app. Once the deployment of the Logic app is successful, it will take you to the Logic app Visual Designer page. There are several predefined templates to choose from. The one that we are going to choose is the one which says when a new tweet is posted. Once you're in the Visual Designer page, you will need to sign in to your Twitter account to authorize your app to use Twitter. Once authorized, you can click continue to go to the next step. You will then fill in the filter word for which the Azure Logic App will listen on. In our case, it is going to be hashtag Azure Logic App. Which brings us to step number 3, where we'll link our Logic App to our Face API and complete the visual workflow. You can do that by clicking on a new step and then action. From the list of connectors, you can select Face API and then configure your Face API by providing the required keys which you would have gotten from the previously created Face API. Then you can add the image from the tweet as an input for the Face API. You will then send out an email with the output of the Face API by linking your Office 365 email account. Once you link the email, you will have several output parameters from the Face API, and the ones that we are interested in is the age parameters. All you have left to do now is to save and then run. In order to see this in action, I'm going to go ahead and upload an image of Tom Hanks and tweet with the hashtag Azure Logic Apps to see if my Logic app picked it up. And sure enough, you can see that it successfully matched the criteria here, which means it sent out an email. Well, that's all for now. I really hope you found this video useful. Thank you very much for watching.